A lot of people today seem to have the idea that you first go to school, then maybe attend university or become an apprentice until you one day get a certificate and then you are considered an expert and know everything in your field. While in reality, life will throw problems at you all the time and you have to tackle them and keep learning probably until you die. And in my experience, the people who are best in their fields are the ones who have embraced that they have to learn all the time. And when I go to these scrapyards here and look for things that I might be able to repair, I'm always thrilled to see what I can find today, because it often is a very big challenge to me. And I just try to embrace that challenge and keep learning while showing you guys how I'm solving these problems. So in that sense, let's get going and see what we can find here today. This looks like a huge stone saw. I remember operating these for hours at a time as a teenager working construction, and frankly, I don't want to go back there. This is a pretty cool fan, and it might be more valuable than many people would think. I'll buy it. At first glance, I thought this could possibly make for a great compressor tank, but it's already damaged rather severely. But now, a lot of work, but probably worth it, 2 huge Bosch hammers. Those are definite keepers. This looks like one of those saws used for meat cutting, but I don't think I have a use for it right now. But look what we found here, a beautiful old spot welder. This is something we will definitely repair. On top of these great finds, I also got my hands on an old steam engine, and we will also repair an ultrasonic cleaner for a friend of mine in this video. So let's go to work then. Let's start with what is probably the biggest find of the day. 2 Bosch GSH11Es. Even though these 2 units are certainly already a number of years old, Bosch still makes that same model and it is a pretty expensive tool. The website calls it the most powerful Bosch hammer tool for horizontal use. While cleaning the units and doing a first outer inspection, we can see that one of the units has a black plastic cover while the other one is all blue. To distinguish the two, I will refer to them as the black and the blue unit in this video. And we can already see that the blue unit is missing the plastic cover of the on-off switch. I can reach the actual lever leading to the switch with my hands though. Since the black one is more complete, I will start repairs on that unit. I'm starting by lifting off the back cover sitting at the back end of the universal motor to check the condition of the motor brushes. You can see right away though that there is still a lot of material left. I also took the brushes out, but there was nothing wrong with them. The hammer also needs a new power cord, and I also want to inspect the speed controller to see if there are any signs of charring or other damage before trying to turn this unit on. In order to do those things, the handle on the back needs to be taken off. For that, you unscrew a number of screws, remove that switch cover under which there are even more screws, and then we can have a look inside. We can see the gearbox as well as the actual power switch and a variable speed controller. The switch has a date code from 1994 by the way, and the speed controller has no signs of damage. It also doesn't smell charred or anything like that. In the next step, I cut a 10-meter rubber extension cord in half and use one half as the new power cord for this machine. The lightning symbol on the heatsink of that speed controller means that the little heatsink on the triax package is directly connected to that piece of aluminium sheet and that there is an electrical connection to the triac. This means that the heatsink can be live when the power cord is plugged in. After doing this most rudimentary of repairs, I dare to turn this unit on for the first time. Both the power switch and the speed controller seem to work just fine, but in order to test the unit properly, a chisel that fits inside has to arrive here first. In the meantime, let's take a look at that second unit then. Just like with the black unit, I started by checking on the brushes. One of the brushes was missing entirely, the other one was worn and damaged. I found that kind of strange, so I decided to just pull the entire rotor out of the universal motor. And here we can clearly see that the armature winding is damaged. And that is why I ordered not only replacement brushes and a new switch cover, but also a replacement armature, apparently third party. Cost for all these parts together 40 euros. And I think in the case of a 600 plus euro tool, that is still justified. Replacing brushes and the plastic cover of that switch should be easy enough. Replacing the entire rotor is a little more complicated. Why is that so? Well, these replacement rotors often don't come with a ball bearing. And that is why we have to salvage this black ring here and the old bearing inside from the damaged rotor and put it on the replacement rotor. In order to be able to somehow pull or punch the bearing off the old shaft, I first cut it off right behind the commutator with a big Hilti angle grinder I repaired in episode 16 of this series. In an attempt to weaken the old shaft, I now clamped it into the 3-jaw chuck of my lathe. But no chance, the drill did not even leave a scratch on the hardened motor shaft. Now I proceeded by cutting off all the parts of the commutator in order to then push the bearing out using my vise, a punch and a second set of hands. Now I was able to push the old bearing onto the replacement shaft and everything was ready to be put back together again. The switch cover was installed. The brushes were replaced and the other half of that 10-meter extension cord was used to install a new power cord to the blue unit. By the way, I also took a look at the mechanical side of things, but couldn't find any damage there. After reassembling the blue unit, a new chisel had arrived, and it was time for an actual test. Okay, so much about splitting a brick, but what about steel and concrete? Let's have a look at that fan then. First of all, what kind of fan is this? What to do with it? And where did it come from? Well, it's from an AC unit like this one. And a replacement fan for this AC is actually quite expensive. So let's see if those costs could have been prevented if whatever company threw it out would have bothered to check what caused a possible malfunction. I'm once again starting off by cleaning everything, also to check for damage all around the housing. I also removed the propeller to clean the grime on the motor shaft. Maybe this AC was used in a kitchen or another place with a lot of grease in the air. After putting the propeller back on, I connect a temporary power cord to the fan. Let's see what happens. As you can see, the motor does eventually spin up, but it does that way too slowly. As you can see here, I can even push the motor in the other direction while it spins up. This is not how it's supposed to be. If this happened randomly, say pushed by a gust of wind, this fan would just blow the air in the wrong direction, which can't be good for the AC. This looks like a classic case of a malfunctioning motor capacitor. So in the next step, I have now disconnected that capacitor, and we're measuring its capacitance with this component tester. It reads a capacitance of 2.4 nanofarads. This is less than 1/1000th of the rated capacitance of 3 microfarads. And that's when I decided to order a 3 microfarad replacement capacitor. and we test again. The capacitor cost me less than 5 euros. More than 400 euros of damage could have been averted. But if there is one lesson I learned from all these scrapyard finds, it's that many companies could not be bothered with troubleshooting and repair on the component level. In this case, it would have been super simple. In more complex cases, it is almost a lost art at this point. Speaking of which, let's turn to a more challenging repair job. This is episode number 18 of this series. In many of the other episodes, which you can find in the video description by the way, I used an ultrasonic cleaner to clean all kinds of parts. Recently, I have wondered if I can build a much bigger ultrasonic cleaner myself. In order to get a little more familiar with the substance, I agreed to repair this ultrasonic cleaner here that belongs to a friend of mine. He, or someone he knows, turned it on shortly after they bought it. But there wasn't enough water inside. The device overheated and now it doesn't do anything anymore. It appears to be completely dead when plugged in. He has already tried to fix it, and that's why we also found a fuse here. So let's open it up and have a look at it. Upon removing the bottom cover, we can see 6 identical ultrasonic transducers glued to a stainless steel basin. They are connected in parallel in groups of 3. Between them, 2 paralleled heating elements are attached to the basin as well. They have been electrically disconnected by someone though. In the front of the enclosure, we find a board holding buttons and 7-segment displays. Under the tape here in the corner, we can expect a temperature sensor of some kind. The sensor and the heating elements are operated in a closed feedback loop, which would normally ensure that the device can't overheat. But as you can see here, there is a rather large distance between the two, and without an adequate amount of fluid in the basin, the sensor would be coupled only very loosely to the heaters. The heating elements could be red hot, with the sensor still at a moderate temperature. I would expect that this is what damaged the device. My friend apparently removed the heaters altogether in order to test if the transducers could still be run on their own. One of the heating elements is damaged, with one of the leads broken off. This might have happened due to over temperature or by applying too much tension while pulling the wires off one of the boards. The right-hand board here contains a switch mode power supply in the upper left corner, probably a flyback converter. We also find 2 relays. The rest of the board contains a driver or resonator circuit to drive 3 of the ultrasonic transducers. The left board is a second version of that same driver circuit for the remaining 3 transducers. There also is a fuse holder inside this power jack. That fuse is burned through and needs to be replaced, and I have already done that. The fuses on the boards have been bridged with wire. I do not recommend to do that. There's a reason those fuses burned through. You're not fixing the issue by disabling the indicator and only fail-safe you have. You must rather find the cause of the overcurrent. Upon closer inspection of that second board, I might have found that cause. If you compare the housings of these 2 power transistors, you can see that the heatsink of that TO220 package on the left is blued from overheating. This component is most probably broken, and I guess that happened when the heating elements overheated the entire device. I have now completely disconnected the second driver board. With the heaters already disconnected, I'm plugging in the cleaner to see if the power supply, controller and right-hand driver still operate. And yes, they do. The cleaner jumps right into action, but expectedly only 3 of the 6 transducers are active. We will now repair the second driver board. After desoldering the blued transistor, I connected to this component tester, and there is a short circuit between 2 of the leads. The transistor is damaged, and the second power transistor was removed as well. And even though it looked better externally, it had the same issue. In the meantime, I had ordered 2 power transistors of the same type. Many of you probably expected these to be MOSFETs. They are bipolar junction transistors though. I first threw them to the little heat sinks. Then we soldered both the transistors and the heat sinks back to the board and cut off the excess leads. Next, I removed the short-circuited fuse and installed a proper fuse holder. Now the board is reinstalled, and the one still working heating element is also reconnected. the second heater is removed from the circuit altogether. It will work. The cleaning fluid will simply heat up slower and probably not reach as high a maximum temperature. Upon reinstalling the fan and putting everything back together, it's time for a real-life test. With the transducers active, we can see these little waves on the water surface. The transducers also emit the usual nasty high-frequency noises. With these settings, the cleaner tries to heat up to 50 degrees Celsius on the left-hand side, with the current temperature being 24 degrees, the blinking number, and the resonators will be active for 31 minutes, already counting down. Some minutes later, the water has heated up to around 30 degrees Celsius. I now also add some detergent to the water, and now I'm placing this ceramic insulator inside. I found that on the scrap as well. I also fill up the cleaner until the insulator is completely enclosed. I had it in there for the remaining 10 minutes and then added some more time. And here it is, already much cleaner than before. Remember the spot welder we found? It is very heavy. It seems to run on an ordinary 230 volts outlet. I haven't really seen anything like it before. It was made by Dalex, which is a German welding equipment manufacturer with a history going back more than 100 years. Until the 1990s, Dalex made all kinds of welding machines. Today, they are specialized in spot welding. This spot welder still has the old company logo on it, and that seems to have been in use until the 1950s or 60s. We can see right away though that the thick power cord is not safe to use anymore. It needs replacing. I will in fact take the entire machine apart, take a look at everything, clean everything, and see what needs replacing. This cable is probably also not the original, as there are several unused conductors inside. In a next step, I remove the side covers of the switch mechanism. This material, apparently protecting these sheets from sparks, is most certainly fireproof asbestos fiber. It is very dangerous, and I will see that I remove it without breaking it. Inside we can now see the switch mechanism in action. It basically consists of two brass rods that pass each other, ensuring only momentary contact before snapping back. Since the spot welder basically creates a direct short circuit through the workpiece at its output, it was necessary to operate it in short bursts only, in order not to damage the workpiece or overheat the transformer. The movable jaw of the spot welder is connected to the transformer's secondary winding via a package of thin, flexible copper sheets. They are bolted to the massive copper rods in the front. It probably took me an hour, but after removing all kinds of screws, pins and springs, I was able to separate the three basic components of the spot welder and free the transformer in the middle. The transformer's secondary winding consists of massive copper sheets, the individual turns of which must be insulated from each other. The transformer must look rather crusty at first glance, but the substance of the insulation seems to be alright. I don't see any clear signs of charring or overheating. It's just old. Most of the metal parts are now cleaned in the ultrasonic cleaner. The old wires are removed and the remains of the green paint are wire wheeled off for the transformer to receive a new coat of fresh green paint. After drying, the connections to the primary winding are renewed and a new mains cable is installed, before everything is then put back together. To test the welder, I will now connect these replacement steel blades to each other. I've been to this thrift store recently. It sells used items to help homeless people with the proceeds, as far as I know. The German word for a thrift store is Sozialkaufhaus, meaning social store. Most of what you find here is clutter, but sometimes, once in a blue moon, there are little treasures to be found, like this steam engine. I was able to haggle a little bit and got it for a good price. So let's see what might be wrong with it and get it going again. The main pulley connecting the steam engine's flywheel with a line shaft is worn out. It is a helical metal spring, the two ends of which are pushed and twisted into each other. But as you can clearly see, it is permanently deformed. The entire machine is pretty dirty, and I would bet that the machine is also very dirty under those covers. I can turn most of the tools by hand, but the little drill press appears to be stuck. I start by cleaning all the surfaces before I turn the model around to bend those little metal hooks by which the engine is attached to the floor. And as expected, we find a thick layer of soot under the boiler. I proceed by scraping it all off. In the next step, I unscrew the model drill press. And after loosening a tiny screw, I can pull the spindle out of the press. Here we find some old grease that has hardened over the years. I remove it with some WD-40 and apply new grease. I also apply WD-40 to the little pulleys in the back. In the meantime, a new belt has arrived here, which I was able to buy for less than €2. Turns out the company still makes them. This tiny funnel also came with the engine, and so did this lubricant here. Another item I needed to order though are heat tablets, known under the brand name S-Bit here in Germany. The little valve is unscrewed from the top of the boiler, because here is where water will have to be filled into the boiler. The heat tablets are placed into a tiny tray, which is then to be pushed under the boiler. This tiny screw will have to be unscrewed in order to grease the cylinder. So let's do it then. Preheated water is filled into the boiler using the funnel. The vent is screwed back in, and lubricant is applied to the cylinder. The S-bit is ignited and pushed in. After a short amount of time, steam escapes the boiler when the little release valve is pulled up. And now, so I hope that you liked this video, and if that is the case, you absolutely should give this a like, because it is the best way to tell me that you want to see more of it. If you want to help more actively, you can support this channel by becoming a supporter on Patreon under patreon.com/tpai, or make a donation via PayPal. A link for that is in the video description. See you soon.